Welcome to a lesson with Dr. Powell. Let's take a look at how we can simplify a Boolean algebraic expression using technique which I call sandwich swallowing. So we're going to be looking for swallowers in this expression. So which is what we'll be doing is we'll be replacing the terms that we see. So these are the terms, and we want to replace them perhaps with simpler terms in the expression, and that's how we're going to simplify this. Now, what are the candidates for what we can choose? Well, we just do this little by little, and we often look for sub-expressions like A and D or A and C or something like that in here to replace it with. And the idea is if we can find something, some kind of sub-expression somewhere, I'll call it E, and let's call this whole expression right here A. So if we can find some expression E such that if we make E true, it forces A to true, that actually means that A was situated between E and the full set, which we'll call 1. So think of this as sets. So E is going to be like a subset of A, which is a subset of 1. And if E is actually true, or setting E to true, so if we set E to be true, so we just kind of merge these, if we merge E and 1, our merges are such that they preserve unions and intersections. They preserve ors and ands. So this is kind of like a logical merging. So if you merge E with 1, then since A is between these guys, it'll actually force A to merge to the same place. It'll be in the same fiber of the merge. So therefore, A would be true. Now, why would that? So if we find some expression such that when we set it equal to true, that's going to force A to also be true, then what that means is that E actually happened to lie below it. That's the only option for E. If this happens, that means that E actually lies below A. So we're looking for expressions that lie below A. Now, if expression lies below A, then that means if you take A and you union on E, since E is a subset of A, it's contained in it, union doesn't do anything. So then we can use E, and E will come in, and if it is a superset of any of these, it'll swallow it whole, and you can replace it with it. So the basic idea is you take you get an expression, and if under the assumption that it's true implies that the whole thing is true, then you have found a swallower. So let's take a look at what we should do here. How should we find these? We'll just, like I said, little by little. You first start by finding a variable that occurs more than once, say, maybe like A. Let's just start by making that variable true and see what happens. The expression would simplify. I mean, think of 1 as being the subset, like everything, and 1 intersects something is just that thing. So this right here would just simply be not B or C, and this would become B or not C. If A is everything and you're intersecting it, it would just be that. Or if A is everything intersecting with something, it's just what you see. And then you get B and not D and C. And what we'd like to have happen is we want this to be true. So do we need to set anything else to 1 to force this to be true? And so we take a look at this and we look at something that might notice that B happens more than once. So why don't we just make B 1? So if we make B, so let's set B equal to 1 as well. So if B were 1, then what would happen? And let's write that down here. So if B is equal to 1, then we end up getting, well, then this would be 0. Oh, 0 and or intersect or something is just 0. So 0 meaning like the empty set. Unioning on doesn't do anything, so you just ignore this guy. So this guy's gone. Over here, you have 1 and something, so it's just that thing because you're intersecting this with everything, so it's just that thing itself. So you get not C, and then you get D and C, and then B is 1, so you just end up getting that, which is not D and C. Okay, so you end up getting this thing. Now we can do a little extra sandwich swallowing if we wanted to here, just kind of thinking about, because the question is this equal to 1? So let's just kind of pause for a minute and see if it's equal to 1. Well, what if perhaps, what if C were 1? Well, if C were 1, then what you'd have is you'd have a D or a not D, which would mean, oh my goodness, you would get 1, you get everything. So, well, that actually means that C is a swallower in this expression, so it can replace anything that is a subset of C. Well, this is a subset of C since it's intersected with C. This is intersected with C subset. So this whole thing would turn into C right here. And C, but that's just what this expression is. So this expression actually, in and of itself, with just assuming that A is 1 and B is 1, actually can be simplified as not C or C using this little sub-sandwiching methodology, which means that's just 1. So this is actually equal to 1, which means just under the assumption that A is 1 and B is 1 forces the whole expression to be 1. You could have also done this by distributing and foiling or whatever else you want to do here. Like you could distribute, for instance, I mean, you could distribute this into here and here. And when you do that, you'd notice that you would end up getting not C or D, and not C or C would just be a 1 with the and would just go away. So you'd end up just having not C or D, and you're ORing that with not D and C. If I'm doing this right, let's see. Let's see if I did that correctly. Let me just double check the work. So not C went in. Let's see, or that, and not C or, but it right. Just one, but you're anding it onto that. So it's like this is like an and 1 in here, but that's gone, and that's ORed onto here. And OR operations are associative. Okay, and then what you could do is see how this is or distributes over this. So you could even just distribute this over that if you wanted to, but then you'd have a 1 and if you distribute over the other one, so C and that would be, so let's see. Well, let's just kind of walk through that one. So think about this maybe, and you just write it out. So not C, and this is just extra anyway, but just kind of because we already know it's 1. But if we had not C or D or not D, right? Because it just, okay, because it distributes to that, and then you have over across the and, you have not C or D or, let's see, not, so not C or D, right? But, and then you're ORing that on to the C, right? And you already have the and there. So if you look at this, oh, well, this is definitely 1, and that's definitely 1 here. So 1 and 1 is just 1. So you'll end up getting that too, because D or not D is 1, C or not C is also 1. Okay, so anyhow, we have just determined that A, if setting A is 1 and B is 1 at the same time, which is actually the same idea as setting A and B equal to 1, literally as a term. So we know that A and B is actually a swallower. So go through here, what is contained in A and B as a subset? Well, look, this is intersected with it, so it swallows this guy. This guy's gone. Good, we got 1 gone. So we know this is A and B, and I think that's it for that one. Okay, we could also do, well, let's look here and notice that we could have chosen C instead of B. So let's do that and see if we can another term. Our hope is maybe A and C would be a nice swallower. Let's just check that out, see how that would work. All right, so let's look at A and C and see if that'll work. It's kind of the idea. So C is 1, then we'll end up getting not B, or, and in this case, we'd get B and Not C would be 0. So B and 0 would just be 0, right? Because that means B and 0 is 0. Then we have OR and C is 1. So that's just D. Or C is 1. So you're ANDing onto that. So it's just what's there, B and not D. Okay. So if you take a look at this and now notice if, let's see, if B is 1, then you actually get D or not D, which is 1. So which means B is a swallower in this little expression, means you can replace this guy with B, but B or not B is 1. So this whole thing is 1, which means the whole expression is 1 if you assume that A is 1 and C is 1 simultaneously, which means that A and C is a swallower. So we can go through and see, oh, look, you can replace that guy with A and C. And oh, you can replace this one with A and C. So which you could just have one instance of it. So you have this or this, or, and then just what's left over, B and not D and C. And this is a simplified version of this expression in disjunctive normal form. In another video, I already demonstrated how to convert from disjunctive normal form to conjunctive normal form. And thanks for watching.